Single replacement reactions can be recognized because you will have an element reacting with a compound. So somebody who's all by themselves and somebody who is in a group. The tricky thing about single replacement reactions is you need to check and make sure that the reaction will actually proceed. And the way you do that is by looking at the metal reactivity series. So these reactions, if they have two metals, so we have sodium and we have copper here, then one of these metals is what we call more active than the other. If the more active metal is all by itself at the beginning of the reaction, then it will react to pair up with the nonmetal or the anion. If the more active metal is already paired up, then the reaction will not proceed, and if you mix those things together, nothing will happen. So the first thing to do when you see a single replacement reaction is to identify the two metals. So let's do that. We already did that for the first one. We had sodium and we had copper. Then you want to find your metal reactivity series. Now this is not something you need to memorize, but something that you'll be given, but you need to know how to use it as always. So for this first one, our two metals were sodium and copper. Since sodium is listed before copper, that means sodium is more active. If it is more active, then the reaction will proceed if it's all by itself at the beginning. And we see that here. Sodium is all alone over here, and so it will have the strength to displace this copper and pair up with the nitrate. So our products will be sodium, nitrate, and now the copper will be all by itself. Now you know that the sodium pairs with the nitrate because sodium is a metal and gets a positive charge. Nitrate is a polyatomic ion with a negative charge. So you'll always have this positive pairing with a negative. You can't have sodium and copper pairing up because both of these have positive charges. And so this can never be electrically neutral, so that doesn't form. So the sodium displaces the copper, giving us sodium nitrate and copper. Because these are ionic compounds, you need to make sure that the charge is balanced. In this case, we have sodium with a positive charge, nitrate with a negative charge, and so it's already electrically neutral without any subscripts. So when sodium reacts with copper to nitrate, the sodium will displace the copper, giving you sodium nitrate and copper. And then the last step is to balance the equation. We have two nitrates here, but only one on the other side of the equation. So we'll put a 2 coefficient here. Now we have two sodiums, but only one over here, so we add a 2 over here. In our other example, we have magnesium chloride reacting with aluminum. The first thing to do is identify the two metals. So aluminum is a metal and magnesium is a metal. So now we want to find those metals on our metal reactivity series. We find them here. We have magnesium and we have aluminum. Magnesium comes first on the chart, so that means magnesium is more active. So if magnesium is all by itself on the reactant side of this equation, then the reaction will proceed. But magnesium here is already paired. That means that aluminum doesn't have the strength to displace magnesium, and if you mix these together, nothing will happen, or there will be no reaction.